class says hello again, Esther. Uh, Looking at section 10.3 today with geometric sequences and series. And with an arithmetic series, we found a common difference, d, and we found that by subtracting one term and subtracting the previous term. So for a geometric sequence, we have a common ratio, r, and we find that by taking a term and, bless you, David, and dividing it by the previous term. So by dividing. So the common ratio in the first example here, we have -6, 9, -13.5. Now we should notice something about that common ratio right away. It's going to be what type of number? A negative, because it's alternating negative, positive. So we must be multiplying by a negative. So d here is just 9 over -6, or -3/2. And in the next one, oh, well, we don't have actual numbers there, but we have still something happening. The basic idea is still the same. We find d by dividing. So d is going to be equal to, and I'm actually going to take the second and third term because they're little smaller numbers to work with. As long as we have two consecutive terms, it doesn't matter. So we take a term, the negative back up there again. A term divided by the previous term, so it's going to be the 4r minus 8 divided by -16r plus 32. Well, we don't want an answer that looks like that. What do we do with that? Factoring can help us here. So we have 4 times the quantity, r minus 2, over, let's factor out a -4 here, -4 times the quantity, 4r plus, that's going to be minus because we're factoring out the -4. Okay. Good idea, Caleb. Let's hold on to that and do that in a separate step, just because we're going to cancel the 4's nicely here. So we have -8. And we can cancel the 4's. Don't lose the negative, though. Be careful of that. And then moving on with that. Now, Caleb suggested that we should have maybe factored out a -16 to begin with there. Since I had already written the -4, we left it. But good idea. So we have r minus 2 over lost the r there, -2 times -4 times r minus 2. At that point, we have another canceling, but this time we cancel the r minus 2's, so we have -1/4 is the value for r. Okay, so pretty simple to find the value of d. Sorry, r. To find the value of r. Thank you. As with arithmetic sequences, we could define them either recursively or explicitly. We're going to do the same thing here. Recursively, we have the formula a sub n equals a sub n minus 1 times r. So we're just multiplying by that value of r each time. If we look at it recursively, okay, let's look at a few different steps in the sequence, or the series, sequence, to see what's happening here. If we had a1, and we multiply that by r, we get a1r. If we multiply by r again, we get a1r squared, and then a1r cubed, each time multiplying the previous by r. So what can we give for a formula for a sub n? Well, each time we have the a1 in there, So our formula is going to start off with A1, but then it's multiplied by r to a power. Ah, good, Luke. That is the n minus 1 power. So when n is 0 or is 1, what are you multiplying the A1 by? R to the 0 power, which is 1. Okay, so that leaves the first term as just plain A1. Okay, so there's your formula, the explicit formula for finding a term of a geometric sequence. Okay, so we want to write an explicit and a recursive formula for this. So the first thing we want to do is find the value of r. So r here is anybody out there? Negative 2. It's 2 divided by negative 1, negative 2. So r equals negative 2. So our recursive formula, a sub n equals a1, which is negative 1, times r, which is negative 2. Sorry, we don't want the value in there. We want a sub n minus 1 times negative 2. For the explicit formula, a sub n equals a1 which in this case is negative 1 times r, negative 2, to the n minus 1 power. So there's the explicit formula. So we can use that idea to find the answers to these questions. We want the 11th term of the sequence, 189, 151.2, 120.96. So we'll probably want to grab our calculator to see what r is here. 189, sorry, 151.2 divided by 189. Make sure you put the proper thing on top. So what that come out to? 0.8. Okay. So for the 11th term, a sub 11 is a1, 189, times r, 0.8, to the 11 minus 1 power. So again, we can grab our calculator and work out 189 times 0.8 to the 10th power. Whether to use the recursive or the other. If I use the recursive, I've got to go through and find the 4th term, the 5th term, the 6th term, the 7th term, the 8th term, the 9th term, and the 10th term before I can find the 11th. So that helps me make my choice there. Yeah, so if you feel like working all that out, then you can go that way. Yes? Yeah. Right. So if it asks for the 4th term, certainly you just could use the recursive formula there and multiply that by 0.8. Even the 5th term, maybe you'd want to just go ahead and multiply by 0.8 twice. But when we're getting out to the 11th term, that's a lot of recursion to go through. So what do we come up with for an answer here? 20.29? Harrison? The recursive? A recursive formula might be used if you were doing something with computers where you actually want to calculate all those terms, something like that. But most of the time, yeah, the recursive isn't typically what you want to use. No. Okay. For the next one, now we got to be a little bit careful here because we're told not A1 but A3. Okay, we looked at one kind of like this yesterday. So if that's A3, what we want to do is kind of think of adjusting it to where that is A1. So if we let this be A1, A1 is 32, then what are we trying to find? Not A12, but not A4. Okay. After A1 is A2, A10. Okay. So we want to find, if we reset this to A1, we want to find A10. So A3 is equivalent to the A1, and A12, that looks too much like a 9, okay, because we lowered the subscript by 2 here, so lower the subscript by 2 here. So this is equivalent to finding A1 equals 32 and find A10. We're given the value of R. So we have our formula that A10 is going to equal A1, 32, times R, negative 4 to the n minus 1 power. So that's going to be to the 9th power. At which point we can just grab our calculator and figure out what that will be. Anybody have it? So negative 8,388,608. Okay. Okay, a geometric sequence can be modeled by an exponential function. Notice in our formula we had an exponential. We had a base to a variable power. So basically the same as our formula. It's some A1 times R to some x power. Restricting the domain to the natural numbers gives us that discrete function where we're just getting points instead of a continuous function where we're getting the whole curve. So we can use that idea to find if I purchased a 1996 Mercury Grand Marquis for $725, if it depreciates 12% per year, what is the value? No, I did not buy it in 1996. I do. It is a 96, and I bought it for $725. Okay. The car depreciates 12% per year. What is the value of the car after 5 years? So, first of all, we want to look at this and say, well, what is R? We're starting at our A1 is $725. So what's the value of R? Got to be a little bit careful here. What? Hint, it's not 0.12. R is 0.88. Because we're finding how much is left on the value. The 0.12 is how much is being taken off of the value. So R is 0.88. So if we want to find the value of the car after 5 years, so we want to find a 5? No. We want to find a 6. Because A1 is the value at the beginning. A year hasn't passed yet. So after 5 years is going to be a 6. So finding a 6, we have a1 times r to the n minus 1. So a6 is going to be 725 times r, 0.88, and to the n minus 1 power, so we want it to the, even though n is 6, the power that we end up with is still 5. Okay? And so we worked that out, and hopefully I worked it out correctly here. About $382. Yesterday we looked at finding arithmetic means, and we saw that there could be more than one arithmetic mean. Today we look at finding geometric means, and the basic idea is going to be the same. So we have two non-consecutive terms of a geometric series. Then all the missing terms in between those, however many there might be, are called the geometric means. Now you may remember way back in geometry, we found something we called the geometric mean. That was for if there was just one geometric mean. Anyone remember how we did that? If you had the numbers, say, 10 and 14, and you wanted the geometric mean of those? No? It was the square root of 10 times 14 was the shortcut. Okay? So if you just have one geometric mean, then you can apply that. But here we're going to have more than one geometric mean, so that's not going to work anymore. Okay, so we're going to use our formula for A1, or for AN again, to help us figure this out. We want to find two geometric means between -4 and 13.5, so I always recommend starting these by drawing yourself a little diagram. -4, blank, blank, 13.5. Because to find what those values are, we need to know, yesterday for the arithmetic, we had to find the value of D to get the arithmetic means. So here we have to find the value of R. So if this is A1, A2, A3, and A4. Christian? An arithmetic mean is when you're finding the terms that go in between things in an arithmetic sequence. A geometric is we're finding things that go in between the terms of a geometric sequence. So the whole way the sequence is built is different. And so they're going to be very different numbers. So we need to find R here. So plugging into our formula, AN, we know AN, A4 is going to be 13.5 equals A1, -4, times R, which is what we want to find, to the n minus 1, so to the third power. So if we divide 13.5 divided by -4 is R cubed, and so we're going to have to take the cube root of each side. So R is the cube root of 13.5 over -4. So calculator and decimal approximation, we'll just go with there. I'm sorry? -1.5? Okay, so that's approximately -1.5. So now we can come back here and say, okay, using the recursive formula, -4 times -1.5 would be 6. So again, we take the 6 times a -1.5, so we're going to get negative, and 6 times 1.5 is 9. And to kind of double check ourselves, let's take -9 times 1.5, -1.5, and we get 13.5. So you can double check yourself by making sure that last term is what you think it should be, what it should be. Similar problem, find three geometric means between 10 and 0.016. We start off again with a little diagram. 10, blank, 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 the three geometric means, 0.016. So this is a 1, and this is a 5. So to find R, go back to the formula, A sub n, so 0.016 is going to equal A1, 10, times R to the n minus 1, so n minus 1 here is going to be fourth power. And solving for R, so dividing by 10, we have 0.0016 equals R to the fourth. So R is the fourth root of 0.0016, which is 0.2. So if we take 10 times 0.2, we get 2 times 0.2 is 0.4 times 0.2, whoops, 0.08. And times 0.2 is 0.016.